let's evaluate an improper integral with an infinite limit of integration and determine whether it is convergent or divergent. Now we are asked to evaluate this integral. The integration from 5 to infinity of dx over square root of x minus 1. This is an improper integral because the upper limit is infinity. And that means that we'll first rewrite it using a limit. And since the infinity is at the upper limit, we will use the definition 1. Where in definition 1, as you can see, it's the integration from the lower limit to infinity f of x dx, and it is equals to the limit as b approaches to infinity, integration from lower limit to upper limit f of x dx. So from the given problem, so from the integration from 5 to infinity dx over square root of x minus 1, we have here now use the definition 1, limit as b approaches to infinity of the integration from 5 to upper limit b of dx over square root of x minus 1. And now this allows us to treat it as a definite integral with a variable upper limit. Let's use a substitution to simplify the integrand, and we let as u is equals to x minus 1 and du is dx. And from the lower limit 5, so if we substitute 5 in x minus 1, we have 4. And from the upper limit, which is b, if we substitute x as b, we have b minus 1. So we change the limits from 5 to b to as 4 to b minus 1. So again, by using definition 1, from integration from 5 to infinity of dx over square root of x minus 1, we have the limit as b approaches to infinity of the integration from 5 to b of dx over square root of x minus 1. And as we change its limits from the lower limit to the upper limit, the integral becomes the limit as b approaches to infinity from integration from 4 to b minus 1 of 1 over square root of u dx. And we can rewrite this 1 over square root of u to u raised to the power of negative 1/2. So we have limit as b approaches to infinity of integration from 4 to b minus 1 of u raised to the power of negative 1/2 dx. And we integrate u raised to the power of negative 1/2. We have 2u raised to the power of 1/2 and substitute b plus b minus 1 and 4. So the and 2 raised to the power of 1/2 can be written as 2 square root of u. So the limit as b approaches to infinity of 2 square root of u, substitute from 4 to b minus 1. After substituting b minus 1 and 4, we subtract them, and so we have here now the limit as b approaches to infinity of 2 square root of b minus 1 minus 2 square root of 4, and square root of 4 is 2, and we have the limit as b approaches to infinity of 2 square root of b minus 1 minus 2 multiplied by 2 is 4, and we have here the limit as b approaches to infinity of 2 square root of b minus 1 minus 4. We can now apply the limit as b approaches to infinity. Now we have here now 2 square root of infinity minus 1 minus 4. And as you notice, we cannot solve it since it fails to approach a finite value, so the improper integral is divergent. Now, by using definition 1 from the previous slide, we evaluated that the given function is divergent.